Space travel has long been a subject of human fascination, a dream of reaching beyond the limits of our planet and exploring the vastness of the cosmos. One of the most iconic and awe-inspiring stories in the history of space exploration is the Voyager mission, particularly the twin spacecraft Voyager 1 and Voyager 2. Launched by NASA in 1977, these spacecraft were designed with a singular purpose in mind: to explore the outer reaches of our solar system and beyond. These two remarkable probes have now traveled farther than any human-made objects in history, and their journey continues to inspire awe and excitement. But even as these spacecraft press onward into the vastness of interstellar space, they are showing signs of wear and aging. Their story is not just one of scientific achievement, but also of resilience, perseverance, and the incredible lengths to which NASA has gone to keep them operational for so long. The journey of Voyager 1 and 2 began in the late 1970s, during an era when space exploration was at its peak. The primary mission was to explore the outer planets of our solar system, including Jupiter and Saturn, and provide valuable data about their moons, rings, and magnetic fields. Both spacecraft were equipped with advanced scientific instruments, cameras, and antennas to send information back to Earth. The ambitious goals of the mission were realized early on, with both probes successfully completing their flybys of Jupiter and Saturn. Voyager 2, in fact, went on to make history as the only spacecraft to visit the ice giants Uranus and Neptune, providing humanity with unprecedented images and data from these distant worlds. After completing their primary missions, both Voyager spacecraft were sent on extended missions, with Voyager 1 becoming the first human-made object to enter interstellar space. For many years, these spacecraft continued to send back valuable data, revealing the mysteries of our solar system and beyond. They offered us insights into the outer edges of our cosmic neighborhood, uncovering new information about the interstellar medium, cosmic rays, and the solar wind. The data they sent back helped us understand the conditions in deep space and how our solar system interacts with the broader galaxy. Despite the extraordinary achievements of the Voyager program, the spacecraft have faced numerous challenges as they journey farther from Earth. The first signs of trouble began to appear in the early 2000s, as the spacecraft's systems began to degrade due to the immense distances and the harsh environment of space. For example, the spacecraft's power supply, which relies on radioactive decay, began to weaken, and it became increasingly difficult to keep the instruments and communication systems operational. This was compounded by the fact that both spacecraft are operating far beyond the range of direct human intervention, making any repairs or maintenance impossible. In recent years, the situation has become even more dire. Both Voyager 1 and Voyager 2 have experienced a series of technical issues that have left NASA engineers scrambling for solutions. The most notable of these occurred in 2022, when Voyager 1 began sending back strange and garbled data. The spacecraft's attitude control system, which is responsible for keeping its instruments pointed toward Earth, had mistakenly tried to route its data through a computer that had been shut down years ago. This led to a situation where the data being sent back was corrupted and unreadable. While the cause of the problem was eventually traced to the malfunctioning system, it took months for engineers to figure out how to resolve the issue. Fortunately, they were able to reroute the data through the proper systems, and Voyager 1 was able to resume its mission. However, that was just the beginning. A few months later, another problem arose, this time with Voyager 2. An erroneous command had caused the spacecraft's antenna to shift by 2 degrees, effectively pointing it away from Earth. As a result, Voyager 2 was unable to communicate with NASA for several months. At that point, the distance between Earth and Voyager 2 was a staggering 19.9 billion kilometers, and it took a full 18.5 hours for a signal to reach the spacecraft, and another 18.5 hours for a response to come back to Earth. In the end, it took 37 hours to restore communication, a reminder of the challenges faced by those trying to maintain contact with spacecraft so far from Earth. Then, on November 14, 2023, Voyager 1 once again made headlines when it encountered another technical issue. This time, the spacecraft was no longer able to properly bundle and send data back from interstellar space. The issue stemmed from a malfunction in the Flight Data System, FDS, which is responsible for gathering incoming data from the spacecraft's instruments and converting it into a format that can be transmitted to Earth. The problem lay in the communication between the FDS and the Telemetry Modulation Unit, TMU, which sends the data back to Earth. Essentially, the FDS was no longer able to send meaningful data, instead transmitting a sequence of useless zeros and ones. NASA engineers initially tried to fix the problem by rebooting the FDS in December 2023, but the issue persisted. This led some experts to suggest that it might take a miracle to get Voyager 1 back up and running. And yet, as so often happens in the world of space exploration, a miracle did indeed occur. In April 2024, after months of effort, engineers managed to get the spacecraft transmitting again. The solution lay in a faulty computer chip that had caused the malfunction in the first place. Engineers worked to replace the damaged chip and reprogram the spacecraft's systems to bypass the malfunction. In the end, Voyager 1 began sending data once again, a triumph of engineering and perseverance. But even as NASA engineers celebrated this success, they knew that Voyager 1's problems were far from over. One of the biggest concerns facing both spacecraft is their aging fuel systems. Voyager 1 and Voyager 2 rely on small thrusters powered by fluid hydrazine to control their orientation in space. These thrusters, which were originally designed to last for many years, have slowly started to fail due to the accumulation of deposits in the fuel lines. In fact, by 2002, NASA had already replaced the thrusters on both spacecraft once, and by 2018, they were forced to switch to a third set of thrusters, designed for course correction. Unfortunately, these thrusters are now showing signs of wear as well, and NASA faces the possibility that they may fail entirely in the near future. In response to these concerns, NASA engineers have implemented a series of measures to try and extend the life of the spacecraft as long as possible. For instance, they have deactivated non-essential systems and prioritized power for the spacecraft's scientific instruments. By carefully managing the available power, NASA hopes to keep the spacecraft functioning long enough to continue sending valuable data. In addition, NASA has developed a strategy for managing the spacecraft's dwindling power reserves, including a gravity program designed to conserve energy by shutting down certain systems temporarily. In August 2024, NASA engineers successfully preheated the thrusters on Voyager 1 by shutting down non-essential systems, allowing the spacecraft to continue operating without overloading its power supply. Even with these efforts, however, the reality is that Voyager 1 and Voyager 2 are not going to last forever. The spacecraft are growing older, and the harsh conditions of space are taking their toll. In the case of Voyager 1, the communication systems have been struggling to send back data, and the thrusters are in a critical state. The spacecraft are reaching the limits of their ability to continue transmitting useful data, and the end of their mission is inevitable. But even when that day comes, the legacy of the Voyager program will live on. These spacecraft have already surpassed all expectations, having far outlived their original mission lifespans, and their data will continue to provide insights into the farthest reaches of space for many years to come. In the case of Voyager 2, it too faces challenges, including the deactivation of one of its science instruments due to power constraints. The plasma sensor, which was originally intended to measure the solar wind, is no longer functional because the spacecraft has now entered interstellar space, where the solar wind is no longer flowing outward. Fortunately, other instruments, such as the plasma wave subsystem, are still active, allowing Voyager 2 to continue collecting valuable data. Like Voyager 1, however, the end of the mission is on the horizon, and the spacecraft's systems will eventually cease to function. Despite these challenges, the Voyager program is an extraordinary success story. These spacecraft were never meant to last this long, and yet they have exceeded every expectation, providing humanity with unprecedented insights into the outer reaches of our solar system and beyond. The data they've sent back has helped us better understand the nature of space, the behavior of our sun, and the conditions in interstellar space. The legacy of the Voyager missions is not just one of scientific achievement, but of human ingenuity and determination. As we approach the eventual end of the Voyager mission, it is important to reflect on the significance of what these spacecraft have accomplished. Voyager 1 and 2 were designed with a lifespan of just 5 years, yet they have now been operating for nearly 50 years, providing data that has fundamentally changed our understanding of the universe. The science they've gathered will continue to shape the future of space exploration for generations to come. Even as we face the inevitable end of the Voyager mission, the spacecraft will continue to fly through the cosmos, silently carrying the story of humanity's quest for knowledge and exploration far beyond the reaches of our solar system.